So now that we've done the volume formula for prisms and cylinders, and we know the volume formula is base area times height, now we can move on to the one base shapes, the pyramids and cones. And the way we're going to do that is by trying to find a relationship between prisms and pyramids, and then between cylinders and cones. We're going to try to find a relationship between these shapes in order for us to find a link from, again, the formula that we did last time, which is area of the base. Don't forget that tells us how many cubes there are in the first layer times the height of the 3D solid, 3D surface, however you want to express it, which basically tells us how many layers. Okay, so what we're going to be doing is I'm going to show you a demonstration so you can see for yourself what this relationship is. Again, we already know that this is base area times height for a cylinder, base area times height for a prism. The base here would be a square, the base here would be a circle. Okay, so you do the area of the circle times the height, area of the rectangle or the square basically, and times the height. Okay, now we're going to relate this to pyramids and cones. Let's start with the pyramid. This is a square pyramid. Notice that this square prism, trying to draw it, trying to show you at an angle, so I apologize, but this square pyramid has the same height as the square prism. That is level, they have the same height, and the base is the same. Notice how this square base fits perfectly in there, and the same base fits perfectly in here. Okay, so the area of the base is the same and the height is the same. I'm trying to find a relationship between this square prism and this square pyramid. Same size base, same height. So the way I'm going to do that is I am going to fill this up with water, and I'm going to pour that in here and see if I can find how many times I would need to fill this up with water and pour it in there to fill that up with water. Okay, so here goes. Pouring water in here, trying to fill it to the fill line, which is where the rectangle, the square would rest. A little bit more, okay. That's one. Doing it again. Here's two. See how many more can fit in there. And there you have it. Exactly three. Three of these square pyramids fit exactly into that square prism. Again, three of these square pyramids fit exactly into this square prism. So what does that mean? Let's analyze that for a second. Okay, so cleaning up this. If the capacity of three of these filled this to capacity, that means that working backwards, this divided by 3 would be the equivalent capacity of the pyramid. Let's say it again. If I fill this up with water and pour it into the prism 3 times, it's 3 fills for me to go from the pyramid to the prism. How can I go backwards from the prism to the pyramid? It would basically be divided by 3 or 1/3. It would work the same way with a cone and a cylinder. As long as I have the same size base, and as long as the height is the same, the capacity of the cone multiplied by 3 would be the capacity of the cylinder. And I'm going to demonstrate this one for you really quick as well. Okay, so here's 1. Kind of hard to get it to exactly that. Here's 2. And there's 3. So once again, it took 3 fills of this cone, poured into the cylinder to fill the cylinder to capacity. Excuse me, that was my son who interrupted me. So it took this, filled up 3 times, poured in there to fill the cylinder up to capacity. Therefore, working backwards, if I take the cylinder capacity and I divide it by 3, that would be equivalent to the cone's capacity. Okay? Let's go back and do some practice problems so you can understand what I'm talking about. Okay, so if the volume of the prism and the cylinder is base area times height, to get to the pyramid or the cone, I would have to divide by 3, or basically 1/3 base area times height. Ta-da! That's the volume formula for pyramids and cones. Base area times height divided by 3. Okay? So practice problems. Let's do this one, number 6. Okay? Notice how I need the height, not the slant height. Slant height was needed for surface area. Height is needed for volume, the height of the solid. So the volume formula here, as I said, base area times height. The base is shaped like a square, so I'm going to use the formula for the area of the square. Oops, don't forget divided by 3. Very important. Always put the 1/3 from the beginning so you don't forget at the end. Okay, so that's going to be 6 times 6 for the area of the base, multiplied by the height of the solid, and then don't forget to divide by 3. That's going to be 36 times 4 divided by 3. So that's going to be 144 divided by 3. And of course, 144 divided by 3 is 48. So it's 48 cubic feet for the volume of this pyramid. Please put the 1/3 in the beginning so you do not forget to divide, because at the end, if you don't divide by 3, the answer is wrong. It would be the equivalent to a prism, not a pyramid. Okay, another example, the volume formula here. If you prefer to put the 1/3 in the front, that's fine. It's the same thing whether you divide by 3 or multiply by 1/3. It's the same thing. So again, 1/3. Now this time the base is shaped like a circle. So pi r squared would be what I would put in place of capital B. Here they're giving me the diameter. So the diameter is 24, so the radius would be 12. So it's 1/3 pi times 12 squared, and then times the height. Again, I do not need slant height for volume. I need the height. So it's 1/3 times 144 pi times 35. Okay, so if I multiply these numbers together, I'm going to get 1,680 pi cubic inches. And if they ask you to approximate, that's going to be 5,277.9 cubic inches. Okay, so we've done a square pyramid, we've done a cone. Let's move on to something more interesting. This one, hexagonal pyramid, 1/3 base area times height. So it's 1/3. Now the base is shaped like a regular polygon. So 1/2 ANS is what I would use for the area of the base. Now, fortunately, they were very nice. They gave us the apothem. The apothem is 5.2. Okay, N is 6 because it is a hexagon, 6 sides. And the length of each side is also 6. The height of the solid, they gave it to me as 10. So if I do the area of the base, I like to do my order of operations first. So that inner network of parentheses. So 1/2 times apothem times number of sides times length of each side. 93.6 is the area of the base. Now we're going to multiply that by the height of 10 and then divide that by 3. And it's going to be 312. 312 cubic kilometers is the volume of that that hexagonal pyramid. Now, the next one, I was looking ahead to the next one. The next one is a square prism with a square pyramid on top. Now, with surface area, it was very complicated. Whatever was covered, you'd need to subtract for this composite figure, but it's not so with volume. With volume, it's actually easier. All you have to do when you have shapes like this, 2 shapes put together, is you get the volume of one, you get the volume of the other one, and you add them. Very simple. You don't have to worry about what's not showing, what's covered, because it's space inside, it's not the surface. So let's do the volume first of this square prism. So if I do the volume first for this square prism, the volume is base area times height. The base is shaped like a square. So it'll be 6 times 6, and then that times a height of 4. That's going to be 144 cubic centimeters for the prism, which is the bottom part. Now let's go to the pyramid. It is a square pyramid. So from the beginning, the volume formula is 1/3 times base area times height. Again, the base is shaped like a square, so we're going to use the formula for the area of a square, which would be 6 times 6. Now, the height of the whole solid. Notice how here it said the height is 12 for the height of the whole composite figure, but part of it up to here was 4. So what is the difference from 12 to 4? The difference is 8. So 8 would be the height of the pyramid. So it'll be 1/3 times 36 times 8, which comes out to be 96 cubic centimeters. So now you have the volume of the pyramid and you have the volume of the prism. So all you have to do is add them. And if you add them, your grand volume is 240 cubic centimeters. And that is the answer for this one. Okay, let's try one more. A word problem, yay. Okay, a little bit complicated, but not too complicated. Okay, the Great Pyramid in Giza, Egypt is approximately a square pyramid with dimensions shown. The pyramid is composed of stone blocks that are rectangular prisms. So this is made up of a bunch of little blocks. An average block has dimensions 1.3 meters by 1.3 meters by 0.7 meters. Approximately how many stone blocks were used to build the pyramid? Okay, so the concept here is let's find out what the volume of the pyramid is. Let's find out what the volume of one block is. And if we divide the pyramid's volume by the block's volume, we'll be able to estimate how many blocks are needed to make this pyramid. So let's start off with the volume of the pyramid. So the volume of the pyramid, sketched badly, I know. Okay, so the volume of the pyramid, it is a square base. So it is a square pyramid. The volume formula is 1/3 times base area times height. The base is shaped like a square. And the dimensions of that bottom of the pyramid are 230 by 230. Now multiply that by the height of the pyramid, which is 146. So if I multiply that, we have 230 times 230 times 146, and then divide that by 3. We're going to get 2574466.667. It probably continues with sixes. Now, what are the units here? This is cubic centimeter. I'm sorry, cubic meters. But looking back at the blocks, are the blocks in the same unit? They are. They are in meters also. We're lucky. No conversions were necessary. Always check to make sure the units are the same before you start comparing. So for each block, it's 1.3 by 1.3 for the area of the base, and then times a height of 0.7. So again, getting the volume of each block is going to be 1.3 times 1.3, and then that times a height of 0.7. That's going to give us 1.183 cubic meters per block. So this is how many cubic meters we have total. This is how many cubic meters each block consumes or takes up. So to find out how many blocks we need, we would take this number, this 257 number, 257,446.667, and divide that by 1.183. So if we do that, okay, if we divide that, we're going to get a total of about 21762. They want us to round to the nearest thousands, not decimal place, but actual thousand. Okay, so the nearest thousand, this would be 21,000. So approximately 22,000 blocks are needed to make this pyramid. Okay, so basically what we did there is we just got the volume formula for a pyramid or a cone. It's the same volume formula as a prism or a cylinder, just with the one extra thing of dividing by 3 at the end. Okay, so going back to what we started with, you get the volume of a prism or a cylinder, but a pyramid and a cone are basically considered as the same prism or cylinder, as long as they have the same size base and same height, but it's 1/3 the capacity. So its volume would be 1/3 base area times height. Don't forget to divide by 3. I recommend you always write down the formula from the beginning so you do not forget. So that should be enough to get you going with the homework. Good luck. See you soon.